Assalamualaikum to our lecturer, Dr. Imtiaz Ali Ibrahim, and to everyone present. Today, we are presenting our final project for BITI 1113 Artificial Intelligence. Our project is MediScan, an AI-powered pill identification system for reducing medication error. To understand why we developed this system, let us look at the critical global issue that motivate our work. Medication error represents a served global crisis. According to data from the World Health Organization, there's error kill at least one person every single day and injure approximately 1.3 million people annually in the United States alone. Financial, this creates a massive global burden, costing an estimate $42 billion annually. There are figures highlight that pill identification is not just a minor mistake, but a major public health hazard to requirement and intelligent solution. This issue equally pressing closer to home. Data from Malaysia Medication Error Report System between 2016 and 2021 showed a steady, alarming upward trend with report error increasing by over 16%. This rising trend underscores the local relevance of our project and the urgent need for accessibility AI tools like MediScan to protect patients and caregivers in Malaysia. The root causes of this error generally fall into two categories: identification challenge and vulnerable group. Pills often share very similar shape, size, and color, which is easily lead to confusion, especially when the original packaging is lost or labels are missing. The heavily impacts vulnerable group such as adult patients on complex multi-drug regimen or caregivers with lower medical literacy. MediScan use artificial intelligence to solve their exit challenge by automating accurate pill recognition.
My name is Nazul Fahmi. My part is to introduce MediScan. I will present our project called MediScan. MediScan is an AI-powered pill identification system. The system uses a webcam and image classification to identify pill in real time. The main purpose of MediScan is to help users recognize pill more easily, especially when the pill name or label is not clear. Okay, next, this slide show a technical implementation of MediaScan. So the system architecture starts with user input to a webcam, then the image is captured and processed frame by frame. After the image is sent to the classification model, the system displays the output result to the user. For the AI model, we use mobile net CNN with transfer learning. The model is trained using Google Teachable Machine. The best part is that Google Teachable Machine runs fully in the browser. This means MediaScan can qualify pill in real time using a laptop or desktop without server installation. The main component of and feature of the MediaScan. The first feature is capture and recognition. The webcam capture the pill image, then the system upload and process the image to identify the pill. The result is shown together with a confidence score. There is also a result function that allows user to scan another pill without reloading the page. The second part is the technical requirement. To use MediaScan, user only need a laptop or desktop with a webcam, a modern web browser such as Chrome, Firefox or Edge. And also the most important part is internet connection. We don't need any installation or programming setup required. Overall, MediaScan provide an accessible browser-based interface with the core AI power function. It is simple, practical, and suitable for quick pill identification. I think that's all for me. Thank you.
So our methodology have four phases. The first phase is through data collection, the diverse field image capture across the very angles, lighting condition and background of the seven field classes with 8 to 12 image each. And the second phase is model training, transfer learning applied on MobileNet CNN architecture via Google Teachable Machine for efficient and accurate classification. While the third phase is for the feature learning, extraction of key visual attribute, including shape, color, size, and surface marking to distinguish between peer classes. And the final phase is prediction and classification. Probability scores computed for each class, highest confidence result displayed as the identified peer. And the MediScan was developed through four structured phases, from data collection and model training to feature learning and final prediction output. For the system workflow, MediScan guides user through a simple, intuitive process from opening the teachable machine learning link to receive an accurate peer identification result in seconds. For the first step, we need to open the apps and capture or upload the field image. And step 3 and 4, the AI model process and predicts field name. So the user open a teachable machine, projecting any modern browser. They either activate the webcam to capture a live image of the peer or upload an existing photo. The image is then passed to the teachable machine classification model for processing. Then the AI will model the analyzed shape, color, size, and marking to predict the pill class. A confidence score is displayed alongside the predicted pill name, giving the user clear, actionable identification result instantly.
Assalamualaikum warahmatullahi wabarakatuh. Uh, Today I will do the demonstration for our project. So first of all, on the left you can see the list of all of our medicine. Starting from first, we have a charcoal that is for wine, and then Mioflex. Mioflex is if you're having a muscle sore, and then oral radiation for radiation, and then we have ST10 that is for the flu. T lozenges. T lozenges is for the sore throat, and then Tilomotil is for diarrhea, and then lastly for our medicine we have the choline chloride that is for if you're having a mouth inflammation or sore throat. And then as you can see, the last one I put a background class to separate from all medicine. So starting at the right, as you can see, all of our medicine is on 0% except for the background that I put as a class. So first I will test our first medicine, that is charcoal. As you can see, the charcoal is at 100%. And then we will test the Mioflex for the medicine. Also the same, this medicine is registered under the name Mioflex. And then we have oral rehydration salt. And then we have CST10. So this medicine detects as a CST10. Then we have T lozenges. After that, we have T lomotil. And then last one, we have decolinium chloride. So that's all for demonstration. Thank you.
So this is the result and performance. All 7 field classes were correctly identified with high confidence. Overall average confidence score is 89.57%. The results align with literature benchmark of over 90% accuracy in control settings. And this is our average confidence, 89.57%, while the top score is 94% and the lowest score is only 86%. And this is the list of our tested items, which is the medicine of charcoal is 94%, Mioflex is 91%, Zesty is Zesty 10 is 92%, T-Lomotil is 89%, ORS 88%, Diqualinium 87%, and lozenge 86%.
Contribution to Sustainable Development Goal (SDG). Now let's look at how MediScan align with global objective. Our project really support UN SDG 3 with focus on good health and well-being. By providing a tool for safe and accurate field identification, we are empowering vulnerable groups such as elderly and those with low medical literacy to reduce preventable medication error. Furthermore, MediScan meets target 3D by strengthening community capacity and managing health risks. We aim to democratize healthcare by moving this AI power tool from from clinical setting directly into the hand of the user. Limitation of MediScan. However, we must acknowledge the current limitation of our prototype. Firstly, in terms of identification constraint, the system is currently limited to only 7 train field class. It also creates sensitivity to environmental factors such as lighting condition, camera quality, and the angle of the field, which may affect the confidence score. Secondly, regarding our scope, MediScan is really an educational tool. It does not provide information on those side effects or drug interaction. Therefore, it is not a substitute for professional medical advice or a clinical diagnosis. Future work enhancement. Moving forward, we have several plans to enhance MediScan. To improve our model, we intend to expand the database beyond the initial sample class and increase the number of training sample to make the AI more robust against different background and lighting. In terms of accessibility, we plan to deploy MediScan as a progressive web app PWA for mobile user and integrate a voice output feature to assist the visually impaired. Finally, we hope to collaborate with healthcare professionals to ensure the data provide is comprehensive, including dose and interaction warning, making a complete safety tool. That's all from our group. Thank you.